so if we go back to the stuff that we are starting with in this chapter, the first thing that we came across was that numbers on the right side of the decimal point also have place names, right? They sit in a certain spot inside a number, just like the numbers on the left side of the decimal do. Miss Malone just silly calls them whole number land and decimal lands. You can call them whatever you want to call them, but it's just kind of easy for kids to kind of relate to that kind of language. So in the whole number land, every digit has a place that it sits, like the ones, the tens, the hundreds, the thousands, the 10,000s. And in chapter 1, we went all the way up to the millions and billions place, right? But in the decimal land, we're not going to go that deep. We're only going to go about 3 digits down, maybe 4, but not that much. But we learned that those digits also have a place name. That's called the tenths place, the hundredths place, thousandths, and maybe even the 10,000th place. But what place is there not in the decimal land? Yes, there's not a once place. And so this is where you have to just kind of like, this is a train your brain situation. I know your brain wants to think that because the first digit in whole number land is the ones place, that then the opposite of that would be the first digit in the decimal land would be the ones place. There is no such place. The first place after the decimal is the tenths place. And we kind of have worked on this. I think you're comfortable with it. So I really don't think it's something we have to revisit. We did learn that in whole number land, the further away you move from the decimal, what happens to that digit's value? Shane? It gets larger. But the opposite happens in decimal land. The further away you get from the decimal in decimal land, Tessa, what happens? It gets smaller. So if we're looking at this specific example, the digit that in decimal land that has the smallest value is what digit? Brady?
4, and that's what really tricked me when we were doing it yesterday and you were helping me.
Yeah.
It was like figuring out that the number that says the highest, that would be in the whole number 10,000s. That tricking my brain to think that's.
And that is what gets people tricked, because when you think of the words like 10,000, you think those words are bigger than a word 10. So your brain wants to think, oh, 10,000s has to be bigger than tenths, but not in decimal land. Because if what we're saying is true, if the further away we get from the whole number land, then that must mean the numbers that are further away are getting smaller and smaller and smaller of a whole. So that's a tricky thing, but we have kind of discussed that and we did work on that. Is everybody good with that? So then on your homework, you came across examples that kind of looked like these, where you had to take words and you had to write them in standard form. There were some like that on your homework assignment. Let's check those and see how you did on those first, okay? And I don't think there was many of those, like number 7 was like that, wasn't it?
Yeah.
What was number 7 as a number? What should it look for? For number 7, you had to write it as words. It gave it to you as a number, you had to put it in word form. What did it look like, Addison?
461,000.
Perfect. 461,000. So that's what it looks like in word form. What about for number 8, Cassie?
2 and 3,000.
2 and 3,000. So perfect. And then you had numbers 9, 10, 11, and 12 that gave it to you in word form, and we had to put it in standard form. So Brayden, what'd you get for number 9? Just tell me the digits that you have on your line.
0.70.
Perfect, 0.70. What about for number 10? Number 10, Hallie.
14 and 1.
Or you could just say 14.1. Good. Just because right now you're trying to tell me out loud what the digits are. Yes, 14.1, that's the digits. James, what about for number 11?
0.119.
Okay, now the number says 19,000. So let's check this out a second, James. 19 thousandths. And what digits did you say?
0.019.
Oh, okay, I didn't hear you say that at first, I heard you say 0.19. But yes, you're right, this is the correct answer. So if you have this is what you gotta have. Because the 9 has to be in the thousandths
So you have to put
place.
0 on the left.
Do you have to put this 0 in the front? No, you do not. Because basically, if the decimal point represents the word and, then what you're saying is that you have a little bit of this and a little bit of that. If you don't have anything over here, you don't have to put it. But some people just do because it helps them to kind of see it better. Okay? So that was number 11. Number 12, yes, Sophia.
So number 12 is 3.003.
Perfect. 3.003. Did you have a question about something else?
I have the same question. I asked
Okay, so no, you don't have to have that 0 in front, but you can put it there. It's not going to change anything if you do or you don't. Okay, it's all up to kind of what you want to do. All right, now some other questions that we had. So on our homework last night, we did have some though that had us do this, where it gave us a decimal, and they asked us to turn that decimal into a fraction. Okay, or maybe it gave us a fraction and we had to turn the fraction into a decimal. This was what numbers 12 or 13 through 18 looked like on the first page. No, actually not that. Numbers 1 through 6 looked like. What did we get for number 1? Max, what did you get?
0.132.
Perfect. You could have had 0.132 or you could have just had 0.132. What about for number 2? Number 2. Yes, Henry.
2.95.
2.95, perfect. Number 3, somebody have Alan.
0.802.
For number 3, are you on page 17?
I'm on page 8.
Go to page 17.
Wait, what was number 1?
Number 3.
0.101.
There you go, 0.101. What'd you ask me, Sophia?
What's number 1? I was lost.
Number 1 is 0.132. And then number 2 was 2.95. And then she just gave us number 3. What about number 4, Rory?
0.21.
0.21. What about for number 5, Brennan?
30.4.
30.4. And number 6, Colin? 0.843. Perfect. Any troubles on those?
No.
No. I think the ones that kind of got some of you just a smidgy were the ones that was asking about the thing called equivalent. And that's because yesterday in class, we never really truly got to this section just because our time in class is so crunched now that we just didn't get a chance to get to this. But it is super simple. And at the end of the day, I had a couple of people who kind of came up to me and asked me how to do these. And I did a really quick example on the board. So if you were any of those people, you may have saw that. If you didn't get a chance to see it, I got some people who sent me emails last night to ask for help for those. And I responded kind of with a real simple way to kind of do this. But what does the word equivalent mean? What's equivalent mean? Yes, Olivia. It does. So whenever you see the word equivalent, I want your brain to think of the word equal, okay? So for homework last night, that section, what it did is it gave you a decimal and it said to give a number or a decimal that was equivalent to the one that they gave you. So here is an example. Number 11 or number 13 says, this was number 13 on page 17. It was 0.09 or 0.9. Okay, this is what the problem looked like. And you had to come up with a number or a decimal that was equal to what you see on the other side. So the very simple, easy way to do this is you can simply add a 0 to the back of the number. Now you can't put it in the front, like in the middle. You you can't really put it in the front, but you can add a 0 or take away a 0 from the back of a number to make it equal. So here's what I'm saying. So your answer for number 13, all you needed to do was keep what you had and then simply add a 0 to the back. Okay? Because 0.9, which is on the left side, is the exact same number as 0.90. Now, technically, they have different names. So, like if I asked you to say this number over here's name, what would you say that number's name is, James?
You would say it is 0.910.
Yes, you would say that number is 0.9. So, what would you say this number's name is, James? Keep going.
0.90.
90 hundredths. And you really don't even have to say the point, because if you say that place name, that hundredths, then we know you're in decimal land. So you don't even have to say the point. You would just say this number's name is 90 hundredths. So you notice how they have different names, but yet they have the same value. And that's because that 0, it's holding a spot now in this number, but it doesn't add any value to the digits. So, does that make sense? So that was one way you could do it, by adding a 0 to the end. Or the other option was like on number 17. So for number 17, Sophia, what's it say? What is,
It's 20.010.
okay, that's what they gave you to start with. So to come up with a number that's equivalent to the one that you see there, you just simply take the 0 that's at the end away. So now your answer becomes 20. You leave what they have, but the very last digit, that 0, you remove. So those two numbers are now equal to each other. They have different names, like this one is called what? What's this one's name? Henry, what would I call that number?
20
And
100.
no, what's the number you see?
Oh, 10,000.
So 20 and 10 thousandths. That's that number's name. But on this side, the number's name is what, Henry?
20 and 100.
20 and 100. So they have different names, but they're actually equal to each other because that 0 at the end doesn't change anything. Who understands this? That was just something that we didn't really get a chance in class yesterday to kind of spend a lot of time going over. But as you can tell, is it a difficult concept? No. Now, let me show you one time when zeros could kind of not make it work. So let's say that I had a number like 0.7, and I said, give me a number that's equal to 0.7. What could you give me? What could you give me? Yes, Brody.
0. Or no,
You could. 0.7 what?
0.
Yes, so you could do that. But here's when it all of a sudden isn't equal anymore. If you decide to put like another digit behind that 1. Now it's not equal. Because now you have totally changed the number. It started out as a 7, now it's become a 701. That's much different. So you can't ever, the only time that it can be equal is if the last digit is a 0. Are you all hearing that? If the last digit is not a 0, then you have completely changed the number. And that's like against the decimal laws. You can't do that. What?
So for number 17, could you add 0 to just 1 0?
For number 17.
Sorry, I have 0.
So back up here to this one, she said instead of taking that 0 away, she actually just put an extra 0 behind it. Yes, you can do that too.
Oh, yeah, that's in the hundred though.
Yeah, but it doesn't change anything because the back of the number contains 0. So
You put so many.
So,
zeros on
you could. I mean, really, if you want to kind of get goofy with it, you could put tons of zeros behind here. It's not gonna change the number. This big thing here is still equal to this thing over here because they have zeros at the end. And do zeros change value?
No.
No. So that's why they're equal to each other. All right, so let's check and see what those other answers were for that section about equivalent. Okay. So for number 13, we did that one. For number 14, you either could have done 0.050, like you added a 0 there to that answer. You could have had 0.0500 if you wanted to add 2 zeros. So, okay. For number 15, you could have had 0.03 because you took away the 0. Or you could have added an extra one like Sophia maybe did and had 0.0300. Okay? For number 16, you should have had 4.64. You could have taken away the 0 and had 4.64, or you could have added an extra 0 and had 4.6400. You all catching on what I'm doing here?
Yes.
Number 17, we already did. Number 18, 0.940, or you could have had just or you could have had 0.9400 or whatever. What?
With the test, with like that decimals, and can I put so many zeros?
No, you may not.
Okay, you know.
I can't do that.
No. I tell you that doesn't change anything just because I want you to know it. But believe me, when you take your test, I don't want a bunch of tests that have 18,000 zeros at the end. So,
That's why
okay. All right. Because our class time is crunched, I know we did page 18 also, but basically page 18 was a repeat of page 17. It was like asking you to do the same thing. So we are gonna, unless there's any questions on page 18, does everybody feel pretty comfortable with the what you had to do on page 18?
Yes. Yes.
Then we aren't even gonna really go over it. We're gonna go into what we have to learn today. No questions on page 18? What? Number 10 and 11?
Yeah.
So for number 10, it says to write each number as a number of thousands. Okay, that's a good question. So what does that question even mean? It means if the words say, or the numbers, sorry, it gives you this, 0.07. Right now, Shane, how do I say that number's name? 700. But they want you to write it as a thousandth. So what can I do to this number that would give it a name of a thousandth? So just add another 0. So the first thing you would do is just add another 0. Now you've written the number as a thousandth. And then it says what else does it say to do? Then write the name. So what's the name of this number now? 70,000. And that's what it wanted as the answer. 70,000. So good question, Shane. Yes.
I put that down because my dad told me it was wrong.
Oh, really? That's okay. That's all right. Just remember, we are, just doing stuff right now. We're in the stages of learning. Moms and dads haven't seen stuff for a long time, and sometimes the book does weird stuff. But yes, that's what it means. So just change it to where it has a name that matches that thousandth place. What?
I did the exact same thing, except why would it want to do? It says us to do the thousands, which basically giving the answer away. So why would it want us to write like the original number? 0.7.
I don't think you had to write this, so,
No, like this, like how it says like we have 7,000. I have 100 because I thought you were supposed to write the first number because they already gave me away the answer for this one.
I don't necessarily follow what you're saying.
Ah.
You said you wrote it as 700ths?
Yeah, because of the first number.
Yeah, but if you look at the directions say to write each number as a number of thousandths.
Yeah, right. Since right the number name the decimal.
Right, so once you have like come up with what this would be as a thousandth, then you write that in word form. That's what it was asking you to do. So it was saying, look at, so like for the number 11, what would number 11 look like if I wrote it in the thousandths? What would it look like? Max?
500,000.
Right, it would be 0.500. That's what it would look like. And if I had to write that in, like write its name, as Max just said, that number's name is 500,000. So you would write the words 500,000. Okay. Make sense? All right, I think you're good on that. So we're ready to move to what lesson 2 is all about. And lesson 2 is about writing decimals in expanded form. Okay? Hang on. Okay. So decimals in expanded form. Now, if we were to follow the book is going to make this very confusing. So we are going to make it not confusing and not really teach it how the book wants me to teach it. Okay? So let's start with what we know. This is new information, so I should see everybody ready to write down new notes. So we cleared up our simple solutions, we collected that, we checked our homework, gone over any questions we may have had in that lesson. Now we're ready to kind of run into lesson 2, and we're not going to use the book because the book does wacky things, so we're going to just kind of learn it in simple form. And that is how to write decimals in expanded form. So the first thing we have to remember is, what in the world is expanded form? Now this is building off of chapter 1 stuff, and we learned this in chapter 1. Xander, what's expanded form?
Let's say you're on a number 721.
Okay, let's do your example. 721. This is Xander's example. And I'm going to write this thing in expanded form.
Then you would put 700 plus 8 plus 4.
Perfect. So Xander has shown us here in his example how I would take a number that's just whole numbers. These are whole numbers, right? And how I would make that thing in expanded form with whole numbers. So today's activity is to figure out how would I do it if I had decimals. Is it going to get harder? No. As long as you know the digit's value, just like he knew that 7's value and that 2's value, it's not going to make this any tougher. Okay? So write down this example. Here we go. The example for expanded form of decimals. Let's start with one that's a little bit easy. 0.76. Okay. Does anybody want to kind of challenge their brain to think, what am I going to do if I'm going to write this in expanded form? Follow what Xander's example in the whole numbers up here is all about. Brady, what do you think I'm going to do?
First, you're
Yes, you do. Think. This is how you exercise your brain. When you challenge that brain. Start with your 7.
you do 70.
What's 7's value? Not 70. No, I don't see the number 70 anywhere in there. I'm just talking about the 7 that's in the 10th place. What's its value?
10.
7 what?
710.
7/10 is its value. So how can I write 7/10. Well, I learned yesterday, I can write that as a decimal or I can write it as a fraction. You tell me, how do you wanna write it? As a fraction? Okay, what does 7/10 look like as a fraction?
7.
Perfect. So that's the value of 7. And then what did I do up here with the yellow number when I got 7's value? After I got its value, what did I then do?
Yeah.
I added it, didn't I? I'm gonna do that down here too. I'm gonna add it to my next digit's value. What's my next digit's value, Brennan?
Oh shit, the 6
What's its value?
600.
600.
That's easy.
That's it. That is writing it in expanded form. All I simply did was give the value of each digit, just like I did in my yellow number up above, and I added each value together. Now, Brady and Brennan chose to do it using fractions, but you don't have to do it with fractions. You could do it as a decimal. So let's explore that. What would this look like if I, instead of doing the 7's value as a fraction, I did 7's value as a decimal? What would that look like?
And it would be 7 times 0.1.
Well, what does 7 look like? What does 7 look like as a decimal? Like if its value is 7/10, how do I write 7/10 as a decimal? 0.7. So that's 7's value. Is that what you said? It might have been what you said. Okay. Then what am I going to do, Cassidy? I'm going to add it to 6's value. Now 6 is in the hundredths place, so his value is 6/100. How do I write the number 6/100 as a decimal? There you go. That's what it looks like as a decimal.
That's so easy.
That is so easy.
So.
That's how you do expanded form with decimals. So, and you can do it either way. You be the judge. Do I care how you do it? No. Everybody has a brain that works its own way. You have to figure out with your brain, the relationship you have with your brain, how does your brain see this the easiest way? Does your brain see it easiest doing the fraction form, or does your brain see it easiest doing the decimal form? However your brain wants to do it works for me, as long as the value is the right value. Okay? All right, let's try another one. So let me get into the book and pull some that the book has. All right, let's try another example. All right, here's example number 2. Okay, let's try. What? Let's try. Hold on. I gotta get to where I need to be. All right, let's try one with the whole number. Okay, 4.263. All right. So again, that's your number. You have to write this in expanded form. So now you just simply have a whole number, but you already know how to do whole numbers in expanded form. So don't make that like trip you up. Okay? So how are we gonna do this? How are we gonna write this thing in expanded form? I want all of you to take maybe 30 seconds and see if you can come up with an answer. This is exercise for your brain. So if you just sit there, you're not exercising your mind at all. And your mind's a muscle, and it only grows when you force it to work. So yes, is this looking a little bit hard? Maybe. You haven't done this before. But use the example that I just gave right up above and see if you can figure this thing out. But if you just sit there and wait for me to just put the answer up there, your brain did not do any exercising and it's not getting stronger. So you're in charge of your muscles in your body, and your brain is a muscle. All right, Max is so excited back there. He wants to tell me that he knows how to do this. So Max, What am I gonna do first if I'm writing this thing in expanded form?
Are you gonna write the number?
I want you to tell me what to write.
4 plus.
Okay, so the first thing he did is has the whole number 4. Because the 4 is in the ones place, and he knows that in the ones place, 4's value is 4. Then he said plus. Okay, so far so good. Keep going, Max. 0.2. So you're doing it as decimals?
Yeah.
Okay?
Plus
Yep.
0.06
Yep.
plus 0.003.
Yay, Max.
That's up the way.
That's in decimal way. But who did it as a fraction and they want to be like, nah, that's not, I did it as a fraction. Brody, what does yours look like?
4 plus, and then put a 2, and then under that we put a 10.
Okay.
And then you do plus 6 over 100 plus 3 over 1,000.
Yay. Good job. That's it. It sounded harder, but it really is not, right?
Yeah.
Decimals in expanded form. Thumb up, thumb down, thumb sideways. How you feeling?
This lesson's so easy.
So it is. So if you had homework and it said to do something like, write each decimal in expanded form, could you do that?
Yes.
Yes, okay. Let's add something new. What if it asked you to write each number in expanded form and the number looked like this? What if it looked like that? It was a whole number being multiplied by a fraction.
You get 7 tenths.
Okay, so what do we get when we multiply these two things together, everybody?
7 tenths.
We get 7/10. Now, some people in here might be going, how did they do that so fast? Well, let me just kind of show you how it looks. If I take this whole number 7 and I put it over a 1, I did not change the value of that 7. It's still 7. I think you probably learned this last year when we were doing a little bit of like division work last year. Okay? So 7 over 1 is the same as 7. So now all we did was multiply straight across. 7 times 1 gave us 7. 1 times 10 gave us 10. So that's where we got the 7/10. And now, how do I make, you could just leave it like that as a fraction, but if it says to show it as a decimal, then you have to turn that fraction back into a decimal, which what would 7/10 look like as a decimal? Yes? 0.7. That's all. So see, sometimes things look scarier than really what they are.
What are they called?
Huh?
What are they called?
This is just called writing a number in expanded form as a decimal. So if you want to give this thing a title, this is how we write numbers in expanded form as a decimal.
Come on, title.
So sometimes they just, an option of expanded form is to just do it however you want, which is like Max chose to do it as decimals, but Brady and Brennan and like James and a few other people chose to do it as fractions. But if the directions say to do it as a decimal, like it did here, you have to make sure your final answer is a decimal. Okay? Try another one of those. Ready? Here we go. Is that one I kind of helped you with?
I just got right.
Try this example. Ready? 8 times 1 over 100.
I don't know. Does this have to be a decimal?
Yes, because that's a decimal. What's this gonna look like? Lily, what's this gonna look like as my final answer as a decimal? 0.08. Alright, now, my class is technically over with you, and Miss Priest's coming for English. So, there is one extra tiny little thing that we're gonna practice when I come back from religion before we actually watch maths. And then we will finish the second lesson. Chapter 2. Yeah. So the book made it a lot more tricky, but I just chose to do it in a simple way. Okay. Alrighty.